Introduction to Smart Parking System. As we can see in the present scenario around us, we see excess vehicles and the ineffectiveness to manage them in the correct order. As the population increases day by day, the rate of utilization also increases and coping up with the numbers becomes a task. This car parking monitoring system project deals with an effective way of finding empty parking lot and managing the number of vehicles moving in and out in displaying the number of empty parking spaces by detecting a vehicle using in-ground sensors and providing display car parking platform. The fully automated smart car parking does not require heavy lines of codes nor expensive equipment to do. It is a simple circuit that built for the specified needs of purpose. This automatic car parking system is used to find the available parking lots and navigate the driver to search for desired parking spaces using LED shows at upper sides of parking lot, thus reducing search time. Problem statement for smart parking system. A parking lot or car parking is a dedicated clear area that is intended for parking vehicles. In most countries, where cars are major mode of transportation, parking lots are a feature of every city and a suburban area. Shopping complex, sports stadiums and similar venues often features parking lots over large areas. The use of car parking monitoring system at a parking lot will help vehicles users to know the availability of a parking location through monitor. Controller and sensor will be placed on the floor of each parking slot to detect the presence of a car. Server collect the results of the sensor and store them in
Objective. First, to make parking process more efficient. Second, to offer safe and secure parking slot within limited area, and it also can be widely used in stadium, theatres, shopping mall, college and many more. Third, to develop an intelligent, user-friendly automatic car parking system which reduces the manpower and traffic congestion.
I'm going to explain to you guys the methodology that has been used to run our project here, the methodology that has been used to solve our problem statement. Okay, so here is the IDE 68K. So this is the coding that has been used to run our simulation. So here is the switch that declare the location of the switch, and then this is the LED address and this is the display address. We use 7 segments. So here is the auto initialize the peripherals, where if I click the run on this simulation, it's going to auto open the peripherals. Okay, so here is the coding that has been used. So this is the task 1, that if the parking that have the slot parking that have been taken is 1, and task 2, task 3, task 4, and follow on. So each of the tasks means the parking lot that has been taken. But for task 8, we used to reset the 7 segment and the switch, okay, to see the problems. Okay, and here is the delay to make the simulation smoother. Okay, so I'm going to run the simulation. Okay, here we open the to run it. So here we click run, so it's auto initiate all the peripherals that I need. So if I click 1, then it will trigger the parking. So it only have 6 left. So say if there is no car into the parking lot, so it don't have the red light that show the parking all is can be entered, and the 7 segments display 7. So if I click, so it's going to be decreased. So here is 2 left parking. So as I told you, task 8 is not for the parking, it's for reset. So here you can see it's reset the number and it's going to turn it off back. So it shows 7. Okay, so the parking is taken 1, 2 parking is taken. So the coding that here show each of the number is in decimal, that if you convert it to binary, then you're going to have 101000. So here is the task that have been given.
In conclusion, automation is a step in the right direction for a future fulfilled in the world of transportation. This design provides an effective solution to the common problem discussed. The smart car parking system was designed, fabricated and tested, which provide accurate results when the threshold distance was calibrated and the obstruction was detected. The switching of LED based on the vehicle in the parking space was instantaneous, based on no vehicle and vehicle detect. The design is flexible and can be altered based on the space available and can be installed even in tight and constrained place. Based on the number of LED detected, a common information board is displayed indicating the count of parking space available. It can be concluded that with correct connection of some simple electrical components, it is possible to create an automatic smart car parking system, thus decrease aimless driving, fuel, and time, as well as making the process of parking considerably simpler.